Hi, good day. Today we're going to talk about BJTs, its basic construction, and ano ba yung mga configurations na ginagawa natin sa BJTs to perform different operations. BJT stands for Bipolar Junction Transistor. Bipolar means that two charges are responsible for current. Kung halimbawa ang electron ay nagmo-move pa kaliwa, ang hole naman ay nagmo-move pa kanan. So two charges are responsible for the flow of charges or current. Junction, meaning meron tayong metallurgic junction sa pagitan ng P-type at ng N-type semiconductor material natin. So sa pagitan nitong dalawang to, meron tayong metallurgic junction and we have the depletion region. Between these two, also, there exists a metallurgic junction and a depletion region. Kumbaga, yung metallurgic junction na yon, yun ang dugtungan ng P-type at ng N-type material natin. Kagaya na lang ng ating semiconductor diode. Ang BJT has three terminals or three layers. The first one, itong letter E na to, it stands for emitter. And then B stands for base and C stands for collector. Okay? So those three terminals have different layers. Those three layers also have different doping levels. Alright? Ang emitter natin, ito yung may pinaka heavily doped na layer. Ibig sabihin, ito yung may pinakamaraming impurities. Therefore, this is the most conductive. Ang base naman natin is the least dope of the three layers, which means it's the most resistive and it's the least conductive. While the collector naman, ito yung medium lang yung kanyang doping level, therefore, its conductivity is lower than the emitter, pero mas mataas ang conductivity ng collector compared sa ating base. We have two types of BJTs. We have the PNP and we have the NPN. So as you can see here sa PNP, we have the P-type for the emitter, N-type for the base, and P-type for the collector. Sa NPN naman, we have N-type for the emitter, P-type for the base, and N-type for the collector. Alright? These are called external power supplies. As you can see, meron tayong double subscript notation. Kapag nakakakita kayo ng double subscript notation, kagaya nito, no? The first one, on the left, this is V sub EE or VEE. It means that it's an external power supply connected sa ating emitter. And the negative part is connected sa ating base. Alright? For this one naman, we have VCC or V sub CC. It means that it's an external power supply na konektado sa ating collector and the positive terminal is connected sa ating base. This is the proper biasing or the normal biasing ng ating BJT. So let's focus on this part muna. We call this the base and emitter junction. It is also known as the emitter diode. Alright? As you can see here, ang P-type material natin ay connected sa positive and ang negative natin ay connected sa N-type material. Therefore, ang base emitter junction natin is forward biased. Dito naman tayo mag-focus on the right side. So, ang ating VCC, ang positive niya ay connected sa N-type and ang negative natin ay connected sa P-type. Therefore, the base collector junction is reverse biased. The base collector junction is also known as the collector diode. So bakit tinawag silang emitter diode at bakit tinawag na collector diode to? It's because kung titignan natin tong dalawang to, we have the P-type and the N-type material na magkadikit, meron tayong diode. The same on the right side, P-type and N-type material na magkadikit, meron din tayong diode. So it's like a back-to-back diode. That's why it's called the emitter diode and this one is called the collector diode. Tingnan naman natin tong NPN, yung kanyang biasing. No? Sa NPN naman, we have V sub EE, ang negative niya ay connected sa N-type, ang positive niya ay connected sa P-type. Therefore, this is forward biased. Dito naman tayo sa base collector junction, negative is connected to P-type, and then positive is connected to the N-type. Therefore, it is reverse bias. Ang normal biasing ng ating BJT is base emitter should be forward bias and base collector should be reverse bias. These are the nominal dimensions of the layers. Kung mapapansin natin, yung kabuuan ng kanyang sukat or length, no? This is approximately 0.15 of an inch. And ang ating base is 0.001 inch. Ang base ang may pinakamanipis na layer. Alright? Susunod dyan yung emitter. And then ang may pinakamalapad na layer ay ang ating collector. Paano ba nag-ooperate ang ating BJT? Tignan natin ang loob ng isang BJT. No? In this example, meron tayong PNP na BJT. We have the P-type as the emitter and N-type for the base and P-type for the collector. Tignan natin yung mga kuryente na dumadali sa kanila. Remember that the base emitter should be forward biased. So let's check again. Positive to P-type and then negative to N-type. Pasok. And then the base collector junction should be reverse biased. We have positive to N-type and then negative to P-type. So pasok pa rin doon sa ating biasing. Alright. Take note class, no? Itong mga external power supplies na to, normally, hindi naman tayo talaga nagko-connect ng direktang power supply sa ating BJT. Naglalagay tayo ng mga external resistors sa different terminals natin to set up the proper biasing. So this is just a representation na kung paano natin ibabias properly yung ating transistor. Alright? For this one, let's focus on the base and emitter junction. Ang kuryente natin na dumadaloy dito is from positive to negative. So that is the conventional flow of charges or the conventional current na tinatawag. From positive papunta dun sa ating emitter, ang pumapasok na kuryente doon, we call that I sub E or the emitter current. As you noticed, papasok yung ating emitter current dito. And another thing is, kung makikita nyo yung subscript niya, it's capitalized to denote that ito ay isang DC na kuryente. Alright. The second one, we have the base current. So, papasok dito yung emitter current natin, lalabas naman dito yung ating base current I sub B. Remember, what we're trying to establish here is the whole flow or the conventional flow. Alright. Etong mga holes natin, dumadaloy dito, and then, ire-repel niya yung majority carriers ng ating P-type. What are the majority carriers of your P-type material? Hindi ba't mga holes? Yung hole na nanggagaling dito, at yung majority carriers ng ating P-type material, ay magbabanggaan. Magre-repel sila. Therefore, yung mga holes na nare-repel na manggagaling dito sa P-type material natin ay tatagos papunta dun sa ating base. Hindi mahihirapan na mag-travel yung mga holes. Bakit? Kasi manipis lang itong base. Therefore, yung majority carriers natin, which are holes na nandirito sa ating P-type material from your emitter, tatagos lang from the emitter to base and then base to collector. Itong arrow na malaki na nakikita ninyo, this represents the majority carriers. Ito yung maraming holes na dumadaloy from emitter papunta ngayon sa collector. Dito naman sa ating base collector junction, meron tayong reverse bias, remember? We have from the positive terminal of your VCC, dadaloy dito, and then ang minority carriers ng N-type material are holes. Itong holes na to ngayon ay magta-travel from the base papunta dito sa ating collector. Yung maliit na arrow na yon, yun yung tinatawag nating minority carriers. Ito yung poles pero onti lang yung bilang. Bakit onti? Kasi ito yung kuryente na na-establish dahil sa reverse bias. Remember, kapag naka-reverse bias ang ating PN junction, onti lang or mababa lang yung level ng kuryente natin. So ulitin natin, no? Dito sa ating base emitter junction, ang dumadaloy dito, ang nanggagaling dito ay ang majority carriers, itong arrow na to. So from emitter to base to collector. Dito naman sa ating base collector junction, ang dumadaloy naman dito ay ang minority carriers. So from base papunta sa collector. Ang majority carriers at ang minority carriers na to nagsasama sa collector ngayon. Alright? Lalabas siya sa collector terminal bilang si IC or I sub C or ang tinatawag natin na collector current. In this case, meron tayong tatlong DC currents na nag-exist sa ating BJT. We have the emitter current, which is I sub E, papasok. We have the base current, which is I sub B, palabas ng base. And then we have I sub C, which is the collector current, which is the combination of the majority and the minority carriers. Kanina ay na-establish na natin yung mga different currents na dumadaloy sa ating transistor using the PNP BJT. Ngayon naman ay meron tayong NPN. Pareho din ang kuryente na dumadaloy sa PNP tsaka sa NPN natin, no? We have I sub E, we have I sub B, and we have I sub C. But anong na-notice natin? Ang PNP, papasok yung I sub E, palabas yung I sub B, and palabas din yung ating I sub C. Dito sa ating NPN, baliktad ang direction because ang ating biasing ay baliktad din. But still, ang base emitter junction is forward bias. We have positive to P-type and negative to N-type. And also, the base collector junction is reverse bias. Negative to P-type and positive to N-type. Ngayon ay makakapag-establish na tayo ng first equation natin para sa ating BJT. Ang first equation natin ay i-relate natin yung tatlong kuryente sa ating BJT. As you notice dito, with your NPN, palabas si I sub E, papasok si I sub B, at papasok si I sub C. Kirchhoff's current law states that lahat ng pumapasok ng kuryente ay equal sa lahat ng lumalabas na kuryente. Ano ba yung lumabas na kuryente? I sub E. Therefore, isulat natin dito yung I sub E. Ano yung mga pumasok na kuryente? I sub B and I sub C. Kaya meron tayong I sub E is equal to I sub C plus I sub B. This is also the same for PNP. Ang collector current naman natin is made up of two components. Na-discuss natin kanina that this is composed of the majority carriers and the minority carriers. Ang BJT ay merong dalawang main functions. Una, bilang isang amplifier, at pangalawa ay bilang isang electronic switch. Ang BJT bilang isang amplifier ay nagpapasok tayo ng isang maliit na AC signal sa ating input terminal and then ine-expect natin na magkakaroon ng mas malaking version nito sa ating output. Depende sa configuration ang magiging output natin. Posible tayong magkaroon ng mas malaki, posible tayong magkaroon ng out of phase by 180 degrees. So, depende sa tinatawag natin na configuration. Yung electronic switch naman, ginagamit natin to turn on or to turn off the device and pwede tayong mag-control ng large amounts of current pero ang pinapasok lang natin ay small amount of current. So, controlling large amount of current but using small amount of current. Yun ang BJT as an electronic switch. Meron tayong tinatawag na different configurations para sa ating BJT para mai-operate natin no, ang ating objective para dito sa ating BJT. Kung gusto ba natin siyang gawin bilang isang amplifier or gusto natin siya gawin bilang isang switch. Ang unang configuration ay ang tinatawag na common base. Dito sa common base, as you notice, ang base natin ay direktang nakakonect sa ating ground. But it's not always the case. Posibleng magkaroon tayo ng resistor dito sa ating base before siya makonect sa ground to establish the proper DC level. Alright? But for the purpose of this discussion, ang base natin ay nakakonekta direkta sa ating ground. Etong nasa baba natin, these are the schematic symbols of your BJT. For this one, this is the symbol for the PNP BJT. As you noticed, ang emitter natin ay merong arrow. Kapag PNP, papasok ang arrow. Dito naman sa NPN natin, still, yung ating emitter ay merong arrow, pero palabas. Kapag NPN, palabas yung arrow ng ating emitter. Sa common base configuration, meron tayong tinatawag na input and output ports. Ang input port natin dito sa common base ay ang emitter. Ibig sabihin, dito natin pinapasok yung AC signal natin na gusto nating i-amplify. At dito naman sa collector natin, kinukuha yung output. So collector is your output terminal. So again, emitter is the input terminal, collector is the output terminal. Since ang ating emitter ay input at ang ating collector ay ang output terminal, ang base ang common sa kanilang dalawa. Meron tayong base emitter junction at meron tayong base collector junction. Ang base emitter junction ang ating input side. Ang base collector junction ay ang ating output side. Ang common sa input at sa output side natin ay ang base, kaya tinatawag siyang common base. Sa BJT natin, kailangan natin malaman kung ano ba yung input current, input voltage, and at the same time, ano ba yung output current at ano yung ating output voltage. Sa common base amplifier or sa common base configuration, ang input current natin ay I sub E. Bakit? Dahil ang emitter ang ating input terminal, therefore, yung kuryente na pumapasok sa kanya or lumalabas sa kanya, depende if it is PNP or NPN, is I sub E. Ano naman yung input voltage natin? Since the input terminals or the input side is composed of the base and emitter junction, ang voltahe natin ay V sub BE or ang tinatawag natin na VBE. So this is the base to emitter voltage. Alright, di ba familiar naman tayo with the double subscript notation, no? Kapag magkaiba yung ating subscript sa ating parameter, ibig sabihin, this is measured with respect to a certain point. In this case, etong voltahe na to is measured with respect to the emitter. So this is the base to emitter voltage. So input current is I sub E. Input voltage is V sub BE. Ang output current naman natin, since kinukuha natin sa collector terminal ang ating output, ang tawag naman natin sa ating output current ay I sub C. While the output voltage is V sub CB or the collector to base voltage. So ulitin ko lang, output current is I sub C, output voltage is V sub CB. Etong graph na to, pinapakita naman dito yung relationship between IE and VBE. Ang I sub E naman ay nakalagay dito sa ating y-axis, therefore this is your dependent variable. Ang VBE naman ay nakalagay sa x-axis, therefore ito ang ating independent variable. Ang I sub E ay nakadepende sa value ng VBE. Habang nag-i-increase ang voltahe ng ating base emitter junction or VBE, nag-i-increase din paunti-unti yung ating I sub E until it reaches a certain value na magko-conduct na siya ng tuloy-tuloy. This is like the characteristic curve of your diode. Kapag na-reach na niya yung threshold voltage or yung barrier potential na tinatawag, na tuloy-tuloy na siya magko-conduct. But kapag hindi pa niya na-reach yung threshold voltage na yon, maliit na maliit yung kuryente, which is virtually zero pa lang. Alright? In this case, it's made of silicon kasi it's around 0.7 bago siya mag-conduct. Itong graph na to, makikita natin yung effect sa output voltage, no? Kapag meron tayong different values for VBE. Halimbawa, ang VBE natin ay na-reach ang around 0.7, ano ang magiging value ng ating VCB? For example, ang VCB ay 10 volts. Remember, VCB is the output voltage. But what if ganito? What if nag-conduct na agad yung ating diode? Mas mababa ng onti sa 0.7. Ano mangyari sa output voltage natin? Kapag mas mababa yung value ng VBE, ang VCB natin ay mas mataas. So in this case, naging 20 volts. What if late na nag-conduct yung ating diode? Ibig sabihin, mas mataas yung VBE. What will happen to VCB? So late na siya nag-conduct, ang VCB natin bumaba. So let us relate VBE and VCB. VBE being the input voltage and VCB being the output voltage. Kapag bumaba ang VBE natin, ang VCB tataas. Kapag tumaas naman ang VBE natin, ang VCB natin ay bababa. Pumunta naman tayo dito sa output characteristic curve natin para sa common base amplifier. Dito naman sa ating output characteristics, ang dependent variable, which is on your y-axis, is I sub C. Ang independent variable natin is VCB. Therefore, si I sub C ay nakadepende kay VCB para dito sa graph na ito. Kung mapapansin natin, habang nag-i-increase yung ating VCB from left to right, anong nanonotice natin doon sa I sub C? Nag-i-increase siya. Alright? But merong certain point na kahit increasean pa natin yung ating VCB, magkakaroon tayo ng tinatawag na saturation level or saturation point. Ibig sabihin, hindi na kaya mag-increase pa ng kuryente kahit increasean mo pa ng increasein yung ating voltahe. So that is your saturation level. In this case, for example, itong part na to, no? Nag-increase yung voltahe, nag-increase yung kuryente, pero it has reached around 3 milliamperes. Na-saturate na siya. Hindi na niya kayang tumaas pa dito sa 3 milliamperes na to. Itong graph na ito ay pinapakita rin yung relationship between IE and IC. Remember, ang IE or I sub E ay ang ating input current at ang ating I sub C ay ang ating output current. Kanina inirelate natin yung I sub C tsaka yung V sub CB. Ngayon, irerelate naman natin ang I sub C tsaka itong ating I sub E. Alright? For example, itong I sub E equals 1 milliampere. Ano ang corresponding level ng I sub C? 1 milliampere din. For example, meron tayong 5 milliamperes of I sub E. Anong corresponding I sub C niya? 5 milliamperes din. Therefore, I sub E is approximately equal to I sub C. Bakit kaya? Balikan natin yung relationship ng tatlong kuryente natin. We have I sub E is equal to I sub C plus I sub B. Remember, ang ating base layer is the least conductive. If it is the least conductive, therefore it's the most resistive. If it's the most resistive, yan yung may pinakamababang kuryente. Ang pinakamaliit na kuryente sa tatlong ito ay ang I sub B. This is just probably in the range of micro or nanoamperes. Ang I sub C natin ay nasa range ng probably nasa milliamperes. So we can delete this one kasi sa sobrang liit niya, we can approximate na lang na I sub E is approximately equal to I sub C. I-relate naman natin yung tatlong parameters na yun, no? Yung I sub C, yung I sub E, tsaka yung V sub CB. For example, ang I sub E natin ay equal sa 4 milliamperes. Ang input current, take note, is 4 milliamperes. Anong mangyayari sa ating output current? Habang ini-increase natin yung V sub CB, what happens to I sub C? Nag-i-increase siya until it saturates, until it maintains a value of 4 milliamperes, which is equal also to your I sub E. So that is the relationship among the three parameters of our common base configuration. Ang ating output characteristic ay merong tatlong regions of operation. Remember, sinabi ko sa inyo kanina ng ating BJT ay pwedeng gamitin bilang isang amplifier or bilang isang electronic switch. Paano natin mai-ensure na magiging amplifier ito or paano natin ma-ensure na magiging electronic switch ito? By properly biasing our BJT. By the way, no, biasing means the application of the DC voltage dun sa ating terminals ng ating semiconductor material. Etong part na to, yung white region na yan, yan ang tinatawag na LAR or Linear Amplification Region or otherwise known as the active region. Diba't meron tayong combinations ng voltage and current sa point na yan. Halimbawa, pinili natin tong point na to. No? Pag pinroject natin pababa yan, may corresponding voltage yan. So roughly, this is around probably 17 volts. Kapag pinroject naman natin to pakaliwa, meron siyang corresponding current which is 7 milliamperes. So, bawat point dito sa area na to ay may combination ng voltahe at ng kuryente. Yung combination ng voltahe at kuryente na yon, kapag yun ang in-apply mo sa iyong BJT, definitely it will act as an amplifier. Etong dalawang region naman na to, itong shaded region, we have the saturation region and we have the cutoff region. So kung gusto natin gamitin bilang isang electronic switch ang ating BJT, dapat yung voltahe at kuryente niya ay nandito sa dalawang to. Kapag ang BJT ay ginamit bilang isang electronic switch, meron ito syempreng on at off condition. Kapag ang voltahe at kuryente ng ating BJT ay nandito sa saturation region, ang BJT ay naka-on. Kapag ang kuryente at voltahe naman ng ating BJT ay nandirito, which is basically parang zero na yung kuryente natin dito, no? Almost zero, no? Ang BJT natin ay naka-off. Ito yung description ng tatlong regions of operation ng ating BJT. Ang una ay ang active or the linear amplification region. This is the operating range of the amplifier. Kapag amplifier ang gusto mong function or operation ng BJT natin, kailangan yung voltahe at kuryente mo ay pasok sa active or linear amplification region. Ang cutoff naman, the amplifier is basically off. There is voltage but little or zero yung ating kuryente. Pagdating natin sa example, ipapakita natin yung theoretical values ng kuryente tsaka ng voltahe natin kapag naka-cut off, and the same with saturation. And lastly, we have saturation. The amplifier is fully on. There is current but little voltage or theoretically zero. Makikita natin sa ating mga example yan. By the way, no, itong term na amplifier, pwede natin gamitin kahit na ginagamit natin yung BJT natin as a switch. But para sa purpose na hindi tayo malito, tawagin na lang natin na amplifier ang BJT or ang BJT circuit natin kung gagamitin natin bilang isang amplifier, which means nag-i-input ng maliit na signal at meron tayong lalabas na malaking signal. At tawagin na rin natin na electronic switch ang BJT circuit natin kapag nag-on at nag-off tayo ng isang circuit or ng isang load. Here are some approximations that we can use sa pagko-compute natin ng BJT parameters. Ang una, ito na-establish na natin to kanina, I sub C is approximately equal to I sub E. The collector current is approximately equal to the emitter current. Dahil nga, ang ating base current ay sobrang liit, pwede na natin siyang i-eliminate. Next, for the base emitter voltage, we can assume a 0.7 volt potential difference for silicon. Most of the BJTs naman are made of silicon, kaya pwede natin gamitin yung 0.7 na yon. Balik tayo dito no, sa ating diagram for the biasing ng ating common base. Remember, the base and emitter junction should be forward bias. That's why positive to P-type and we have negative to N-type. Di ba't parang diode dyan? Silicon diode na naka-forward bias, meron tayong 0.7 volt na potential difference. And that is also your barrier potential or the threshold voltage. Another parameter para sa ating common base ay yung tinatawag na current gain. Kapag sinabing gain sa electronics and sa communications, meron tayong quantity na dinedivide. Ano ba yung dinedivide natin? Output quantity divided by the input quantity. In this case, if we're talking about current gain, that's the output current divided by the input current. So titignan natin ano ba yung na-gain, ano yung in-increase ng ating output, no, in relation to the input. In this case, meron tayong tinatawag na alpha. Alpha is the current gain ng isang common base. Hindi ba't sa isang common base, ano yung output current natin? I sub C. Sa common base, ano yung input current natin? I sub E. That's why output current I sub C divided by the input current I sub E is equal to the current gain alpha. Makikita nyo dito, ang ating alpha merong subscript na DC dahil gumagamit tayo ng DC values. DC na collector current and DC na emitter current. Ideal value ng alpha is 1. Bakit nga ba ang ideal value ng alpha is 1? Remember, meron tayong approximation na I sub C is approximately equal to I sub E. So kapag dinivide natin sila, that is equal to 1. But practically, ang value nito ay sa pagitan ng 0.9 to 0.998. Ibig sabihin, yung mga common base na circuits in the real world, ito yung mga gagawin natin na circuit for the common base, no, ay merong value ng alpha sa pagitan ng 0.9 to 0.998. Why is it slightly less than 1? Ano bang mas malaki talaga, I sub E or I sub C? Remember, ang heavily doped layer ng ating BJT ay ang emitter. It means that it's the most conductive. Susunod dito ang collector. So nakikita nyo na yung idea. If it's the most conductive, ibig sabihin, it has the most free carriers. Ibig sabihin, ito yung may pinakamataas na kuryente. Mas mataas ngayon ang I sub E compared sa I sub C. That's why practically, ang value niya is less than 1. Kapag alpha naman ang kino-compare natin, ang numerator natin is delta I sub C, which is the change in I sub C. Ang denominator naman natin is delta I sub E, or the change in I sub E. That is called alpha AC. Ano nga ba ulit yung ibig sabihin ng word na transistor? So para ma-illustrate natin yung ibig sabihin ng word na transistor, ay meron tayong simple diagram. We have the transistor amplifier. This is called the transistor amplifying action. Paano ba nakakapagpalaki ng signal ang ating BJT? Dito sa ating diagram, meron tayong PNP na BJT. Meron tayong input signal na AC, which is equal to 200 millivolts, and meron tayong load, which is equal to 5 kilo ohms. This is just a representation para ma-explain natin kung paano gumagana ang transistor amplifying action. Hindi dito pinapakita yung DC bias niya. Hindi rin dito pinapakita yung mga external resistors to establish the proper bias. Again, this is just a simple representation. Another parameter is the input resistance or the input impedance. In this case, it's 20 ohms. And we have another parameter, the output resistance or the output impedance, which is 100 kilo ohms. Ang input resistance or impedance ay input property ng ating amplifier. Ang output resistance or impedance ay output property ng ating amplifier. So these are the parameters of your circuit. Una ay i-calculate muna natin yung kuryente. Kung mapapansin natin dito, ang input signal natin na 200 millivolts AC, take note this is AC, ay nagpo-provide ng input current na I sub I. Ang input current natin na yan, kung mapapansin nyo, ay pumapasok sa emitter. That's why it should be called I sub E. But I'd like to correct this one. This should be I sub E na small caps dahil this is an AC quantity. Alright? So I sub E, small caps, ang ating subscript, is your input current I sub I. Paano ba natin i-compute yung input current? I-divide natin yung input voltage by the input resistance. In this case, ang ating input voltage ay 200 millivolts AC divided by 20 ohms. So that is equal to 10 milliamperes. Ang pumapasok na kuryente dito na AC ay equal sa 10 milliamperes. Next, how about our load current? Remember, ang load current natin ay lumalabas dito sa ating collector. Therefore, that is also your I sub C. Pero di ba meron tayong approximation? I sub C is approximately equal to I sub E. So kung anong value ng I sub E natin, which is your input current, that will also be the value of your load current or your output current. Again, I'd like to correct this and this one. This should be small caps and this should be small caps because they are AC parameters. Therefore, if the input current is 10 milliamperes, the output current also is equal to 10 milliamperes. Next, we're going to solve for the output voltage. Ang output voltage natin is the voltage across the load. That's why it's called V sub L. Paano natin i-compute yung output voltage? It's just V equals I times R. V is unknown, I is known, R is known. Therefore, we can multiply 10 milliamperes by 5 kilo ohms. The output voltage now is 50 volts. Okay? So, from 20 millivolts, naging 50 volts siya. Can we compute the gain? Alright. Anong tawag do sa gain na yon kapag voltage ang usapan? We call that voltage gain. The voltage gain is represented by A sub V. Di ba sabi ko sa inyo, kapag gain, it's output over input. If it's voltage gain, output voltage over input voltage. Ano ba yung output voltage natin? Yung V sub L, which is 50 volts. Ano yung input voltage natin? V sub I, which is 200 millivolts. Di-divide natin to, makakancel yung volts. So, the voltage gain is equal to 250. Ano ibig sabihin yan? Nagkaroon tayo ng 250 na voltage gain dun sa ating circuit. Minultiply natin input by 250, nakakuha tayo ng output na 50 volts. That is what we call the transistor amplifier or amplifying action. Kung mapapansin natin, ay meron tayong kuryente sa input at meron tayong kuryente sa output. So, nag-transfer tayo ng kuryente from input papunta sa output. So, ibig sabihin yan, nagta-transfer tayo ng kuryente. Transferring current from what? From input to output. From input resistor to output resistor. Kaya meron tayong transistor. Transferring current from input resistor to output resistor. Transistor. Hanggang dito muna tayo. No? If you have any questions about this lecture, i-post lang natin dun sa ating group and I'll try to answer you right away. So that would be all, and thank you.